I can see that Dr. Alok has already here on dais. So may I request other panelists, Debbie, yeah, please join us on the dais. Dr. Shikha, ma'am, may I request you to join us? Any, please join us. Dr. Sinha, Mr. Sinha, Dr. Dang, please. Usually my colleague Nishta would have done the MC for this session. I have literally stolen the opportunity because I wanted to give you a background about this session. Maybe this is the first time we are doing this session, and I'm feeling very blessed that we have such eminent people here. And the reason we wanted to do this session because, if you see this t-shirt and maybe in the back you see the URL. So I have some of my friends also wearing that t-shirt. So we announced this project last year in InnoHEALTH itself. So in a way, this session is like a 1-year progress, if I may. And we started or conceived this project with an ambition that we want to help 1 million people in India with, let's say, primarily with type 2 diabetes, right? And if luck, I can say I'm just destined or very lucky. I had some incident last year, and the moment I was out of hospital, the first flight that I was taking was from Hyderabad to Delhi, and I was taking sitagliptin, maybe you know these, litagliptin's molecule. So the flight, I was sharing a seat with an American who was from Musk, and he was the chief chemist of Musk, and in 1996 he invented that molecule. So that was the first person, I met when I thought we should do this. So he explained me for 2 hours, what should I do? My HbA1c was 12. Then immediately in few months I could get it to 6, right? Just with very simple advice. Maybe I had huge motivation, right? And maybe a lot of people don't have that motivation, but maybe it comes sometimes because of personal shock. And one thing led to another. So some of the people here in the panel, I had the opportunity to meet in advance, right? We visited ma'am's office recently. Dr. Arjun, we have been talking for some time. And I was in Bio Europe in Copenhagen. And I had this dream that I wanted to go to Lund University Diabetes Center. And there I met Annie, in Copenhagen. And next day I was there in her office. And then I discovered, because I was in Stockholm a few months earlier than that, and somebody told me, if you're doing anything in diabetes, you have to go to Lund University Diabetes Center. And then when I was in Copenhagen, I was thinking, it's a half-an-hour train journey to go to Lund, and if I could know somebody there in Lund. And magically, Annie comes walking. We meet her. I was with Pathvi, my colleague, and she agrees that she will host us next day there. I think the date was around 8th November. It's World Diabetes Day or something of that sort. So this is how, to me, it's a very magical moment. And we had some issues yesterday to get Annie here in India. She was almost in India, but not in India because she was having some visa problems, but here is she. So without further ado, may I request Annie Chandy from Lund University Diabetes Center, please share what is the work that you are doing there in Sweden.
So I'm Annie Chandy. I work as an innovation officer at...
Maybe you can use the mic.
Yeah, sorry. Is this better? Yes. I work as an innovation officer at Lund University Diabetes Center. I'm also connected to the tech transfer organization of Lund University, where we help researchers with interesting commercializable ideas to translate them into startups or licensing out these opportunities to other companies. And I'm very happy to be here. I am very glad to be able to come back to India. I have origin from Kerala, so I'm especially glad to be here today. So I thought I would start with a brief background of Lund University and the Diabetes Center, and then move into some of the unmet needs within diabetes that we are trying to address and I'll do sort of 3 projects which I will sort of dig a bit more deeply into. So Lund University, it was founded in 1666, so it's the largest university in all of Sweden. It has faculties in all kind of areas, so spanning from life science to social sciences and engineering. We have about 7,400 employees, which is very large by Swedish numbers because we have a population of around 10 million. There are 42,000 students. And let's see. Yes. And then Lund University Diabetes Center, it's one of the largest existing diabetes centers. It was founded in 2006 when the center received a large grant from the Swedish Research Council. And we have about 400 people working in all aspects of diabetes. So the overall mission is to unravel the pathogenesis of diabetes so that it can lead to treatment. So, I mean, I think that you are even more aware, just as aware as I am, about the epidemic in diabetes. So, about 1 in 12 adults have diabetes, and this is projected to increase to about 1 in 9 people in 2045. And the largest increase will be in low income and middle income countries. And there are some unmet needs in diabetes that I have tried to list here. One is that at the moment, I'm speaking from a European, perhaps an American sort of setup, because I'm not so familiar with the Indian model. But the ADA and the ESD has recommended that diabetes is not treated as or type 2 diabetes, I should say, is not treated as one disease, but that personalized treatment options should be offered. So at the moment, it's one size fits all. So you go from an oral, and from an oral, you start with one, which is usually metformin, and then you add other oral anti-diabetic treatments. And when you fail to control your blood sugar, you go on to take insulin. The ADA and the ESD now recommends that you look at the patient from a more individual perspective and try to sort of match the treatment to the disease profile. Another unmet need is that all of the medications that are available today, they do not actually do anything to either halt or reverse the disease. So a large unmet need is that to find treatments that could have disease-modifying effects. And a third need is perhaps to treat and to try to prevent disease before it is already initiated, because there is hypothesis saying that once you have in early diabetes, even when you sort of diagnose the disease, you have already sort of set the scene for complications. So even if you treat intensively, after a while, you will still have had sort of the complications are already set, so that it's difficult to prevent them. So if one could find modes to treat the disease before, ideally before onset, to diagnose people before they have disease, then one could prevent diabetes complications. So I'm going to present a project that has had a lot of interest from the outside world. It's been cited in the media across the world, and the primary investigator is Professor Leif Group from Lund University, and he's also partly in Finland. So they have used way to, by data-driven method, to analyze 5 parameters, and it's HbA1c, C-peptide, HOMA-IR, HOMA-beta, and they have, by using these 5 parameters, they have used algorithms to cluster these individuals, and they found that people with diabetes could be clustered into 5 different populations. One is people with severe insulin-resistant diabetes, and they could see that people with severe insulin-resistant diabetes, they had low insulin sensitivity, they had quite good glycemic control, but the risk of kidney disease was very much increased in this group. A second group was people with severe insulin deficient diabetes. So they are sort of quite resembling in a way, they have type 2 diabetes, but they resemble in a way people with type 1 diabetes in that they have low production of insulin. They have also a poor glycemic control and highly increased risk of retinopathy. So the implications for these findings, I mean, these are early days, but it could be that if you classify these individuals already at onset, because these people were clustered on data that were sort of available already at diagnosis, the implications would be that people with severe insulin deficient diabetes, they should be perhaps treated with insulin very early in their disease to prevent retinopathy. And a second group, the ones with insulin-resistant diabetes, they should perhaps be treated early on with insulin sensitizers. That is to avoid kidney disease, but of course this can only be proved in a clinical trial. The other two groups that were found were severe autoimmune diabetes, and this cluster sort of coincided with people exactly more or less with people who have who are currently classified as type 1 diabetics. So those treatment recommendations would be applicable that are already available. And then 2 other groups were the ones with moderate age-related diabetes. So they have quite good blood sugar control as the people with moderate obese-related diabetes. So these people do not perhaps need to be so very closely monitored as the one with the severe diabetes profiles. And the ones with severe diabetes profiles should also perhaps be more closely monitored by the healthcare system, so that you can keep their blood sugar in a very tight control already from the beginning. A second project that is now a spin-out company from Lund University is, I'm going to briefly describe the mechanism that the scientific PIs sort of could, how do you say, pinpoint. And it is that if you have hypoglycemia for a long time, they found that ion channel, which is usually located in the surface of mitochondria, it's called VDAC1. It is overexpressed, and it's also translocated to the cell surface. So one of the function of this ion channel is to transport ATP out of the cell, out of the mitochondria, sorry, into the cell. But when it translocates to the cell surface instead, ATP leaks out from the cell, and the beta cells. This mechanism was found in beta cells. They lose their ability to produce insulin, and by blocking, this is the last channel, last picture there. By blocking this ion channel on the cell surface, either with an antibody or with a small molecule, one could get non-functional beta cells to produce insulin again. So it's a spin-out from Lund University, and it's also it's partly owned by the holding company of Lund University, LU Holding. It's located in one of the incubators in Malmö, and the whole idea of the company is to treat beta cell dysfunction based on fundamental molecular and genetic understanding of the disease. So these are the founders. Professor Claes Wollheim is a well-known beta cell expert, and Associate Professor Albert Salehi is also a very known scientist within the diabetes field. So the basic notion is that beta cell death is irreversible once you have diabetes. But current understanding, one is sort of moving away from this idea. So one has understood that only 20 to 25% of beta cells have died when you have diabetes. So the rest of them are sort of dysfunctional. And also there's been pioneering work from UK showing that if people lose weight up to 6 years after diagnosis, diabetes actually completely reversible. So the goal of the company, which is called Abraceo Pharma, is to develop a first-class disease-modifying drug to reverse type 2 diabetes and to get the beta cells to go from a non-functional to a functional beta cell in a durable manner. And this is, it's more or less describing what I mentioned, is that if you look at the progress of type 2 diabetes, you go from from a normal individual, and then you have pre-diabetes for 5 to 7 years. And after that, you have early diabetes. In 5 to 7 years, the disease is still reversible. So the idea is to try, in the first instance, is to try to treat the people with early diabetes, but it could also be applicable at a later stage when the healthcare system has models to treat people who are sort of before disease. So the team behind the company is Dr. Tara Heichner, who is the CEO, and Dr. Christian Hansen. And they have a lot of experience from startup companies. And Dr. Christian Hansen, he comes from Novo Nordisk before, and he has put several diabetes drugs on the market from Novo Nordisk. So briefly going to the data in a DBDB model, it's a mouse model for type 2 diabetes. One could show that treating the DBDB mice with a drug that targets the ion channel VDAC1, the mice did not develop diabetes. And the red line you see is it's the time that the animals were treated. You can also see that after the withdrawal of the treatment, the mice stay normal glycemic for a while until the blood sugar creeps up. So that sort of gives an indication that it could have disease-modifying effects. This was also shown in beta cells isolated from deceased donors. Since we are at the diabetes centers, we have access to beta cells both from normal individuals and people who had type 2 diabetes. And one can see in the right-hand panel that if you culture the beta cells in high glucose for a while to try to mimic hyperglycemia, you can see that by adding an antibody, which blocks VDAC1, the ion channel, the cells can produce insulin again, and that to a certain extent. Yeah, okay, thank you. To a certain extent, when you isolate type 2 islets from type 2 donors, these beta cells could again secrete insulin. So we are currently have a program in place, and we would like to conduct a first-in-mind trial in 2024, and we are currently seeking funding to a phase 1/2 trial in 2023 in type 2 early diagnosed type 2 diabetes patients. And the last project that I will present is about prevention. So Dr. Yang de Marinis from the Lund University Diabetes Center has found that a protein called follistatin is highly overexpressed in normal individuals long before they have type 2 diabetes. And they have used artificial intelligence, deep machine learning, and looked with genome-wide associated studies, and they have used human cell models in vitro and found in 8 different cohorts with about 8,000 participants that you can predict type 2 diabetes with extremely high sensitivity and specificity, that is accuracy, already 4 years before onset of disease. And that opens a window for lifestyle modification already before disease onset. And the idea is to spin out a company from Lund University where the idea is to classify individuals into 4 different groups where high risk and very high risk individuals are given advice on intensive lifestyle modifications. So that is about the 4 projects the 3-4 projects that I wanted to present, and I leave you to ask questions or have comments if you'd like. Thank you.
Maybe you can have a seat, and during the panel, you can contribute. because we are running on a tight schedule. But I thank you, Amy, for these wonderful scientific presentations, because, she's being typical Nordic, very humble and modest, not over marketing in that way. But I think these scientific breakthroughs are going to have huge impact, on how we look at diabetes. And you could also see the Nordic planning that she's talking about 2024 and all that. So while we are probably in India in very hurry, how should we catch the bull by horns? So I now request Dr. Arjun to moderate this session. Yeah, you could sit there as well. We could give you a mic. Okay, yeah. And over to you.
Thank you. Thank you, Sachin. And thank you for that really interesting presentation. So I'll start by saying that firstly, I'm extremely humbled to be moderating this panel and exceptionally thrilled to be discussing the topic of combating diabetes in the diabetes capital of the world, where it is said that more than 60 million people have the condition, and this number is expected to reach more than 100 million in the next 10 years. So what I'm going to start by saying is that the future is now. So this is basically the name of a hip hop album, but what it actually means is that all future takes birth in the present, and we shape and define it right here and right now. So without wasting much time, I'll go on to the questions. And my first question would be to Dr. Alok Chopra. And sir, treating diabetes, where to start? Medicine, diet, and exercise? I would request you to give us your priority sequence. Anything missing in this sequence or anything you would like to add?
Hello? Yeah. Yeah, thank you. Thank you all. Well, as far as sequence is concerned, if we have to give a sequence, it has to be started with nutrition and driven by nutrition. And I think everything else follows. In my view, nutrition would be the driving force of reversing diabetes.
It's extremely important to note that South Asians, including Indians, actually developed diabetes a decade before the Western population, and also at a lower weight compared to the Western population. Dr. Sharma, if I could ask you, what is the exact role of the gut when it comes to type 2 diabetes?
So, interestingly, we are, in modern times now we're talking about the gut biome and the ecosystem or the environment of the gut leading to many things, which could be your deficiencies of vitamins, to diabetes, to even your emotional health. Now, in Ayurveda, I mean, if I quote Ayurveda, the gut always has been the center of treatment, and most of the treatments in Ayurveda were always around how do you detoxify, how do you balance the gut. So, if I have to say that the first point of treatment of diabetes should begin from the gut. Now, why is it the first point? Because that's something which is very tangible, something which can be immediately done with a patient, because it's something which is DIY, do it yourself. Once the instruction is given, the patient can start following it. The second, obviously, is depends on the other two parts of diabetes management, which is how do you get the patient to become more active, and third is how to help him to manage his parasympathetic responses, which is your stress, which is the way they're thinking, how they're processing their, the daily issues or problems. So, but definitely my area is nutrition. So I would say gut biome is one of the most important things. One of the most important things is how do you diagnose that the gut is unhealthy. Of course, you have symptoms, but how do you diagnose?
Ma'am, do you think the Indian diet also plays a role when it comes to diabetes type 2? And why would you think that Indians are more prone to diabetes at a lower age and a lower weight?
So I have a hypothesis because, so one of my hypotheses is that in India, we use oil in most of our cooking, maybe the tropical climate or whatever.
Thank you, ma'am. Dr. Sinha, the next question I would address to you. And when we talk about diabetes and actually diagnosing a pre-diabetics, what diagnostic tests do you feel that we have in India? What do we not have in India? And what are your views on the diagnostic modalities currently available?
Good morning, everybody. See, the tests that are available in India, we have got basically first is the for lab investigation, we do the lab investigation. Apart from that, we have got these glucometers, which we keep it for home care. Basically, there are two common things available in India, and the difference between these two is we are using fresh blood, whole blood in the glucometers in our home care setting, and we are using the plasma blood or the serum blood in your lab care setting. So there is some amount of variation in these two results. But if you want to monitor it, you can monitor with either of these. But you have to think about your previous ratings, and basically the difference is around 10 to 15%. So we have to make, there are some glucometers available in which, as per the ISO standard, they recalibrate it so that you match it to the lab thing. So the ratings will be almost similar to the lab. Now these are two devices which are both are invasive. We are now moving towards non-invasive devices. There are 2-3 devices world over. They are being researched for the past 2 to 3 years, and I think within the next 6 to 8 months we will have the non-invasive devices where you can. There are two kinds of things. One is like pulse oximeter. You just put it the sensor on your earlobe, and then you will get the readings in a non-invasive way. Second is you generate a lot of acetones when you are diabetic. So by breath analysis, you can have the reading of those things. So these two technologies are being researched, and they are very positive findings on those things. And within the next 6 to 8 months, we will have this. Another one is your the tears in the eyes. You have devices where you can have a laser scan, and then you can have the scattering effect, and then you can see how much is your blood glucose, because the blood glucose is related to your tears in the eye, or the ocular fluid that you call it. In this, we have got slight limitation. Because if you have conjunctivitis or other inflammation in your eyes, then the results will be not be accurate. But by and large, for screening purposes, these results are quite okay, and we can start for screening purposes. You can use them. So the second thing is that apart from these monitoring devices, we have got continuous monitoring also. These are the instant monitoring. Then we have continuous monitoring, where you have a sensor which is pricked into your, you keep it on the shoulder or in this side, and then you cover that. And after around, let's say 4 to 5 or 6 days, then it go on recording the data. So after 6 days, then the doctors will pull it out, and then it has got battery and Wi-Fi connectivity to a computer. So there you can have the trends, and in the whole week, how you have progressed towards for your this you are taking the medication, how the medications are affected, what are the food that you have taken, and by how it is increasing your sugar level. All these things you have a trend, and you can by analyzing the trend, the doctors can tell you that okay, if you have taken this kind of food level, then you should avoid this this kind of food. So, and there are a lot of things happening in this within this 6 to 7 days. You really analyze a lot of things, but then the patient has to cooperate. Patient has to in the diary, the patient has to write down. At this time I have taken the food. This was the food. At this time I have taken the food. This was the food. And doctors do advise that It's basically because you are taking too much of carbohydrate. This thing is you're not able to stop it because you are taking carbohydrates more. That is the problem in India. We are taking more of carbohydrates. I was in Seychelles, I remember. We went to a dinner to a Seychelles friend. What he gave me just this small amount of rice and whole of those fish. So that is how, I mean, if you increase the level of protein and fats in the diet, so we can have a good effect there. Second thing is that I will give my personal example. I am a diabetic. My father is a diabetic, and my grandfather was a diabetic. So I had a huge risk. By controlling the diet, I did manage to control it. But just 5-6 months back, my father got a brain stroke and he was paralyzed. So that stress suddenly increased my sugar level. So for the past 5-6 years, I was able to manage to control with dietary habits. But with this, it shot up so much, the stress. It shot up so much because my mother is already paralyzed and the father getting paralyzed, it's a huge risk. So then I started taking medications. For 3-4 months I took the medications. Then I started to research how to reverse it. You will be surprised to note that I started taking Gomutra, and within 2 months, now I have left all the medications. I am not taking any medication now. So within 2 months, all my diabetes has been reversed, and I have got, because we are all diabetic, so we keep the glucometer in my home. My wife is also diabetic. I advise her also to take this, but she will not take it because not everybody is comfortable with Gomutra because you have pungent smell. Then I researched further. Because the pungent smell is because of your ammonia. So there are some companies who have removed this ammonia and fortified it with tulsi. I took that also for another 2 months, and I am finding it quite. I'm really encouraged by this result. That my medicines are no more there, and I am quite in control of my diabetes. I'm monitoring it quite on a weekly basis. So this is.
Thank you, Dr. Sinha. So, Dr. Debbie, what do you think about from a patient perspective? There are any unmet needs in the area of innovation, motivation, adherence, diagnostics, and behavior change, since you've done so much extensive work in the same non-invasive glucose monitoring devices? Could you tell us a little bit more about any innovations that you would like to share?
Great, yeah, thank you. So my background, I'm an endocrinologist working in the NHS, but also an academic, and I do a lot of work through NutriHealth, a company that we've been working on digital health solutions for people with diabetes. I think, just taking a step back, we know that 80% of the cost for diabetes is on complications. So it's the treatment of heart attacks, strokes, kidney failure, blindness. So if we really want to drive down the cost within the system, then it's about focusing on risk factors and focusing on prevention of complications rather than the high cost of treating these acute complications. So that's always been our focus, is to see actually diabetes gives us a fantastic window of opportunity from the time that people are diagnosed through to the time that they may develop complications. And if we can pick up those risk factors early and treat them, then we can have a massive reduction in cost, a massive reduction in complications. And the two ways to focus on risk factor reduction is to get the patients to self-manage better and to focus on clinician management as well, to make sure that people are being screened, that the eyes, the feet are being screened regularly, that we're intervening with very low-cost medications at an early stage, treating with things like statins and if we need to, metformin, but the real focus on patient self-management. So coming back to your question about the patient perspective, absolutely, we need to, the primary focus here needs to be how can we get people with diabetes to better manage their condition. So we need to support them. It's not just about delivering knowledge, but that's important. We need to help people understand why they develop diabetes, what are the risk factors,
How can we support them losing weight, becoming more active? We know from the UK research, if people with diabetes lose on average about 10% body weight, then as you've heard, about 70% can cure themselves of diabetes completely. And this is mainly in a population who have diabetes less than about 10 years. So we need to really focus on that. I think there's two main ways we can do that. One is by supporting them through healthcare professionals. Physicians are very busy, so we need to be thinking, can we in a low-cost way upskill our healthcare service, giving nurses, educators more advanced roles in helping supporting and motivating patients. But also another low-cost way is to use technology more effectively. So just to share an example, in Scotland we've developed a self-management platform for people with diabetes. It's available to everybody in the country with diabetes at very low cost. The Scottish Government pays for it. It costs about £1 per patient per year. I think it's about 100 rupees per patient per year to run the system. And it gives people with diabetes access to all the educational material they need, online courses. They can access their health records, so patients themselves can see all their blood results, they can see all the clinic measurements that are done, and it helps empower them because they understand their disease, they understand their targets, they see the results, but they also see where they should be achieving better results. And we link in data from the blood sugar meters and from things like Fitbits and activity monitors, so that we can give them automatic feedback on their results, their targets, what they should be achieving, and we can push them towards educational resources. And we can deliver this in a really low-cost way by using data, algorithms, rules, to push the information back to patients in a completely automated way, which supports the healthcare professionals when they're trying to motivate the patients. So I think technology is really important, and I can talk for hours about the sorts of technology advances that can help improve people with diabetes. But it's using technology and low-cost upskilling of the workforce to focus on preventative care that I think is really going to drive improvements in our system.
Thank you, Debbie, for that. So actually, I was reading an article and it says that 10 years from now, the biggest diagnostic lab would not have a single machine in it. And they talk about this phenomenon change where it will be a lab in a chip. So basically, you have a wearable that's embedded inside you, something like a non-invasive glucose monitoring device, and then that uploads everything to the intelligence cloud. So extremely interesting. I'll be out of a job, but otherwise, coming to the burning question to you, Dr. Chopra, is diabetes 2 really reversible?
Yes, in a broad sense, yes. And I'm going to exclude the people who have some autoimmune component or type 1 diabetes or all the latent adult autoimmune diabetes. I'm not including them in this discussion, though we are working on that. But majority of the people of type 2 diabetes that I have treated, I have managed to reverse those disease completely. To understand this, I think we need to understand a little bit of the biochemistry, and we need to go back to our ancestral past. See, our genetic code has not changed for about 30,000 years or so. So if the genetic code is not inheritable, what is? Epigenetics, which is the hottest subject of today. So epigenetics is literally how we can actually change our gene expression to be able to adjust to the changing lifestyle. A very nice analogy I give about epigenetics is that if your life is like a movie and your DNA is the script, and if Woody Allen directs it or Steven Spielberg directs it, it's going to be very different. So what I'm trying to say is that diabetes is not an inheritable disease. The epigenome is inherited, which is a modifiable risk. That is one. So based on that, another thing that our ancestors had was that they were primed to store fat because food was scarce and they could live many days without eating. And guess who did that for them? Insulin. Now, insulin's main action in the body is still storing fat and reducing fat burning. And most of us don't realize that, but we're stuck with it. We don't need that property of insulin today, but we're stuck with it. Of course, insulin's main job is to put the sugar back into the cell, but this is the primary action. So when we eat sugar, the response of insulin is huge. Protein is somewhere in the middle. When we eat fat, there is no rise of sugar. If there's no rise of sugar, there is no insulin response. If there's no insulin response, there is no message to the body to store fat. And by eating number of times, each time we raise our sugars, the insulin brings it down 4, 5, 6, 7 times a day. apart from giving a very variable metabolic balance, it's also giving a message to store fat 5 to 7 times a day. So your liver gets fatty. When the liver gets filled, it exports it to the pancreas. When the pancreas gets full, it exports it to the eyes, hearts, kidneys, and nerves, and that's where we are. So for me, anybody who has a deranged body, body composition analysis is diabetic. Well, you call it pre-diabetic or pre-diabetic. You can't say I'm slightly pregnant. So the deal is that you are pre-diabetic if your body composition analysis is not right. And I know, you said that's the right time to intervene is that, but I think any time is right. I have treated people who have been on insulin pumps with 300 units of insulin, people taking 160 to 180 units of insulin. They're all well. They lost 20 to 30 pounds. They're off their pricks. They're great. I mean, it's going on very well. Now, of course, sustaining is the issue here. When we say that we can reverse diabetes in 3 weeks, I mean the sugar is replaced. We are not treating the sugar, we're treating the metabolic defect. The metabolic defect will take about 3 to 6 months. The insulin resistance may take years because of the memory, or the molecular memory. But the point is that at one stage, it is reversible. You maintain it, it's done. The whole onus is on the carbohydrates. Anybody take a guess? In the American Diabetic Association, currently, if you Google it, it says 55 to 60% carbs, 25 to 30% proteins, and 5% fat. And you start looking like that pyramid. We need to turn it around. Now, this translates to about 300 grams of carbohydrates every day. Does anybody know in the audience how much our body needs? How many carbohydrates do we need in grammage? Do we need? Any guess? It's a 4-letter word. There are 2 words, both are 4-letter words. Well, the answer is 0 or none. Now, do I really mean it? Yes, I really mean it. Why do I mean it? Because carbohydrates are not essential nutrients. What are essential nutrients? Those that our body cannot make, or those we cannot live without. There are 4 mechanisms by which the body makes carbohydrates. Number 1 is new glucogenesis. When we fast for a while, some amino acids get converted into sugar. Growth hormone is secreted when we fast because that's one of the modalities. And it gives you a big bolus of growth hormone so the muscles don't burn. And in this process, sugar is formed. Glucagon wakes up once there is no insulin, produces a little bit of carbs. And also our gut microbiome harvests sugar from the fiber. So there are 4 mechanisms. We know guys like Anna Hazare who fasted for 23 days. Why didn't he die? 4 major mechanisms that our body is making carbs, right? So we don't really need them. I mean, you may be used to them, and it may be sounding very strange what I'm saying, but the truth is we do not need any carbs. And I've been on a relatively carb-free diet for about 6 years. I don't have diabetes, but I have great health. So proteins we need to eat. We just heard that all the fats are made from sugar. Any excess sugar is converted into fat. Little bit is used for energy, little bit is stored in our muscles and our liver as glycogen. But unfortunately, the storage space of liver and glycogen combined is just 5 grams. Even if you have 5.1 grams of sugar, that 0.1 is taken by insulin and stored as fat. So the storage capacity is like your wallet, or the storage capacity of fat is like your Swiss bank. Or you can take a refrigerator, take an apple and take it out. A deep freezer is your fat storage. So if you do not eat any carbs, all the fats come into the circulation, and finally they start burning your saturated fats, your oxidation of all the fats, and you recover. It's as simple as that. I mean, I'm making it simple. There's a lot of troubleshooting, and there's a lot of other issues that come up. But by and large, most people with type 2 diabetes are reversible. I'm working a lot on type 1 diabetes and also the adult onset diabetes, and we are finding some markers which can tell us what to do. And I would love to take your help in this, because anything to convert this deadly disease, which is not a disease, it's a nutritional disease, and it needs a nutritional answer to treat it. We don't need any medicines. In fact, I say that the moment you start, you see, the problem is that we think that it's a lock and key mechanism, that there is a lock, which is insulin, it's not allowing the sugar to go in. It's not a lock and key mechanism, it's an overflow mechanism. The insulin is, I mean, when we give insulin or we give sulfonylureas, it's actually trying to put the sugar back into the cell, but that damn cell is so full of fat, it has no place. You're pushing the cell apart, the cell bursts, and you get damaged. The organs get damaged. So it's an overfill mechanism. Every day we put insulin. It is, in fact, I say the moment we start insulin, in most type 2 diabetics, you're actually signing your death sentence. I really mean that. I'm not mincing words at all. It's like, you're sitting on a bag which is full, and you want to put more clothes in it, you keep sitting on it, the bag bursts. Or if you go to Japan sometime, you will see these guys trying to push people in the metro, and another one, that's what is happening. It's an overflow mechanism. And I have another theory about insulin resistance. It's not really insulin resistance, because insulin is still doing its job in storing fat and not allowing the sugar to get to the cell. So how come the same insulin, the same cell, the same insulin receptor is super sensitive to some actions and resistant to the other? It's not a resistance. It's not really a resistance. So, I mean, I could go on and on for hours on this, but the truth is that this is the cause. We do not need insulin. We do not need sulfonylureas. We need insulin sensitizers, yes. We need things like GLT2 inhibitors, which actually are letting not the glucose enter into the blood from the urine. We need things which do not fill the cup or empty the cup. So that's okay, as far as I'm concerned. But other medicines are not okay. And I wish we understand this at this level. It's easy to treat it. I've done 45 since I started my new center, 45 documented metabolic reversals, and about 530 or 540 on roll. Really, I really mean this.
Thank you, sir. Thank you, sir, for that very simplified explanation of whatever you explained. It was like I was in med school again and I was having a fun class with a fun professor. Thank you for that. Yes. Dr. Debbie, when we were speaking earlier, you had mentioned regarding the work of Professor Roy Taylor Newcastle and his studies on diabetes reversal. Could you give us a quick overview, please?
Sure. I think it just backs up a lot of what you've said, but they really certainly led the charge in the UK around diabetes reversal. So their approach was to take people with diabetes, type 2 diabetes, who were averaging a weight of around 100 to 110 kilograms, and they put them on a very low-calorie diet. So it was an 800 kilocalorie diet for around 6 weeks, 6 to 8 weeks. And what they were able to show over that short period of time was that in 70% of those people, they cured themselves of their diabetes, they reversed the diabetes. And when they looked at the physiology of it, they looked at insulin secretion. And these were people who had been told your pancreas has stopped working, you're insulin resistant, it's never going to wake up again. But actually, within days of going on this low-calorie diet, their pancreas gland started producing normal insulin again, having a normal insulin response. And over a matter of a few weeks, they were able to take their HbA1c down to non-diabetes levels. And so it shows the very immediate effect of these sorts of diets. And their hypothesis is, a lot of it is about where you store your fat. So having fat storage around the pancreas, around the liver, so there's intra-abdominal fat. When we fast, we lose that fat very quickly. And so that allows the pancreas to wake up very quickly, start producing insulin, and take you back to normal physiology very, very quickly. So, their work has really helped. That was in a laboratory setting. What they've now done is taken this into a randomized control trial where they've rolled it out through general practice. Because a lot of people said, that's very well, you can do this in a laboratory with 20 people, but can you do it across the country at scale? So they've now proven that they can do exactly the same thing by delivering this diet through primary care, through nurses in a primary care setting, giving low-calorie supplements, getting people to eat as much vegetable as they like to get their nutrients, low-calorie supplements, 800 kilocalories a day, and they've seen the same extent. Once people get to their weight drop, they then can maintain them on a normal diet. So they don't need to keep taking 800 kilocalories for the rest of their lives. But after 2 months, they can go into a sensible diet that will sustain them at their new weight, which is about 10 to 15 kilograms below their starting weight. And they can stay in that diabetes reversal state. So really encouraging results, and I think it's completely changed our mindset in the UK when we speak to people with diabetes, not to say this is a lifelong condition, but to say, actually, you can reverse this, and that's what we should be aiming to do.
May I just add one
Please,
little thing here?
please.
See, not that I like having bariatric surgery or advising bariatric surgery, but the truth is that it works. Now, what we have found is that most markers and the reversal of beta cell action and pancreatic fat happens even before they have lost weight. So it's not the weight that is going on. That means already when you're not taking in carbs and you're not taking thin, the pancreatic function recovers, the islet cell function recovers, pancreatic fat disappears, and the markers go away. So this is real proof. And you can do this. Once I put this, I do the continuous glucose monitoring on myself every now and then. And one day I took a whole glass of concentrated pomegranate juice, watermelon juice, and poured some orange juice in it, and my sugar was 205. Hello. How easy it is to become diabetic, and how easy it is to treat it. Just a simple experiment. These monitoring devices are really something else. And now we are finding a way to do a B2C program, and where we can, this to everybody, and the devices are going to even have the acetone in it. And so it will be both, you are working out where the ketosis is happening and how it is working.
Thank you. Dr. Anuradha, the next question is to you. So since we're talking about reversing and eradicating diabetes, what is the kind of effort you think is needed if we were to solve this, probably like a polio campaign to eradicate polio that we had? Can it be done in the next 5 to 10 years, or do we have to live with it considering the resources that we have?
Thank you, Dr. Dang, for your question. So after hearing a lot about markers, medicines, I'll come on to a very basic thing. Let's talk about numbers. Globally, the prevalence of diabetes, I read, is 425 million adults are currently suffering with diabetes. Out of these, 72 million are contributed by Indians. So you all might be in a shock that 1/6 of the global population of diabetes is contributed by Indians. I come on to what Annie started with, that 1 out of every 12 individuals is a diabetic. So, and she said that by 2045, this will become 1 out of 9. And I recently read that the number has already become 1 out of 11. So if we look about in this room itself, if we have 100 people here, almost 10 out of them have a risk of developing diabetes. So that's the kind of problem that we are looking at if we are looking at diabetes. And to come to your question, Dr. Dang, that how can we address this in a mission mode? I was recently looking at a video which was by the Google CEO, Mr. Sundar Pichai. And he said that they are using deep learning systems to address a problem like diabetic retinopathy, in which this deep learning system would assist people to help them give an expert diagnosis of retinopathy, since retinopathy is a leading cause of blindness. Now coming on to a thing that I was discussing with Dr. Chopra in the morning, he said that we never address the cause of the root cause. So the root cause here is there is expert diagnosis which is not available in the country at peripheral locations. But why this expert diagnosis is not available? The cause of this root cause is we do not have enough trained physicians to address a problem like diabetes. So coming on to how do we address this problem at a mission mode, we at the Public Health Foundation of India, I work with the training division, we gave an effort in the year 2010 to somehow bring this epidemic and address it in a mission mode. What we started with is, we started training primary care physicians and enabling them in at least screening, diagnosing, and managing at a primary level. What this will lead to is, it will lead to less queuing at the tertiary centers, it will reduce the cost of treatment, and then diabetes can be addressed at a very initial stage. So this is how we thought that it can go in a mission mode, and now since we are completing 10 years, we have trained 25,000 physicians in diabetes management. And this is how the government can also think. Now Ayushman Bharat is there. Incorporating this kind of trainings in their mission mode can bring a lot of change in the country. And that's how I think that can be one thing we can bring a change with.
Thank you, Dr. Anuradha. Actually, just to break the monotony, I'd like to ask how many people here in the audience are diabetics or have a first-degree relative who's a diabetic? Okay, I feel that's about 30%. And how many of us do feel that diabetes is really reversible? Amazing. So that's a majority. Wow. Great. So moving on, Dr. Shikha, my next question will be addressed to you. So we've spoken so much about diet and nutrition, etc. But ma'am, do you feel there's a role of non-nutritional factors also when we talk about diabetes?
Yes, absolutely. Like my esteemed panelist just mentioned about stress. Now, stress is a very important contributor to diabetes, and we all know that during pregnancy, during surgeries, the patient's blood sugar goes up because of a transactional stress, and similarly, stress has a huge component in diabetes management. Now, what is the root cause of stress, and what are the things which can work on stress? The first is breath. Breath management, any kind of exercise which can manage your breath, which of course you have pranayam, you have other kind of kriyas. And the second is exercise. Now, when I really look at diabetes, exercise and breath, what really comes out is that when a person is stressed, the last thing on earth they want to do is go and exercise. The last thing on earth they want to do is actually eat healthy. They want to eat junk at that point of time because that is their habit. That's their habit. They've been habituated to having a certain kind of food, which is their kind of food which helps them manage the stress. So when I look at these non-nutritional factors, they actually contribute in a large way to the lack of management of diabetes despite knowing what to do. The second aspect is, of course, is that we are not eating organic food anymore. We are eating food which has tons of chemicals. So most of the foods which we eat today, if you look at packaged food, the number of preservatives there, the number of strange sounding names which actually are not food, they are non-nutritional. So those kind of things which are also contributing to diabetes, because we were talking about metabolic pathways. Now in metabolic pathway, we never learnt on how a preservative is going to affect a metabolic pathway, or how a chemical color to make the the packaged food look brighter and better is going to interfere and affect the metabolic pathway. So I think these are few things which we also need to consider. Fundamentally, all of them are choices. And how do we manage choice, or how do we encourage correct choices is the big question.
Ma'am, what about sleep? Does it have a role?
Absolutely. So, yes,
sleep?
Thank you for mentioning. There have been enough researches out there which have mentioned that sleep has a direct impact on sugar also. If you don't sleep well for a day, the next day you watch your sugars go up. And sleep is also one of the most understated things, because we kind of say, oh, sleep is something which is natural, normal, so we don't talk about it. But really, I think we need to help people sleep better. Now, that is something which sounds strange today, but the reality is with so much of screens coming up. I mean, we have so many screens in our homes today. We have 2 screens which are individual, which are 2 phones. Then we have Kindle, we have a laptop, we have a television. So our off-screen time is hardly there. And these are all stimulants because we are consuming information, entertainment, or quizzes or games. So which means fundamentally our sleep pattern is really decreasing. Our sleep quality is decreasing. Now, how do we fix that? Can devices also help us? There are possibilities.
So ma'am, when we talk about non-nutritive factors, what I really feel, and if Dr. Debbie, you can comment on this also, that the huge world of wearables, for example, you were mentioning Fitbits, etc. Now, when you talk about non-nutritional factors, definitely these wearables can help us monitor not only the vitals, but also these other activities, etc. as well.
Yeah, no, I think that's right. So there's a huge number of different ways that technology can support people with diabetes. Wearables is one of them. I think the obvious things are sort of monitoring things like activity, you said, and that can be used to help motivate people in terms of achieving better step counts and working towards targets in terms of activity, but also monitoring sleep patterns and things as well, as we've heard, and using data to feed back to people. So I think it's one thing using technology to monitor, which could be blood sugar, which could be activity, which could be sleep.
Also, we have things like scales, which can be Bluetooth to and other Internet of Things devices, which can bring data into the system. But it's then how do we then use that data to actually turn it into behaviour change? And I think that's the biggest challenge. And that's where the area of things like artificial intelligence can really help us. So we can bring the data together, and this is what we're trying to do as well, is bring data from the electronic health record system, data that patients are recording from these sorts of devices, but actually turn that back to meaningful knowledge for both the clinicians and the patients. So that might be delivering prompts, notifications, motivational support for people with diabetes, feeding back to them on their targets and trying to prompt them towards a better place in terms of their health. AI can also help support around things like personalising the treatment response. So the more information we can gather with people, from people about their mental state, about their daily habits, about... Ooh. Shall I keep talking? Okay. Their daily habits, where they go, where they work, you know, all this sort of information that we can gather from things like GPS systems, from phones, from Google, can also help inform us to give very personalised, detailed feedback to that individual person that will support them on their kind of day-to-day journey and minute-to-minute management of their diabetes. So I see huge possibilities in those areas.
Great. Dr. Chopra, do you want to
Yes,
remark
I just
on
wanted to bring the subject of the very vexed subject on fruit. I'm not going to demonize it completely, but I'm certainly not glorifying it for two reasons. Number one, the fruit that we get in the market is so bad that if you find out what's going on, it's not just in India. In fact, somebody comes back from somewhere in Europe and says, you know, there's a peach this big. Peaches were never this big. You know, when you go to the country, you see an orange with a little shriveled up guy, you know, which knows it. In fact, I believe that God did not make fruit for us, you know. It was made for the birds and the animals so that they could propagate, they could eat the seeds. The seeds come out from the fecal matter. Our fecal matter gets into the toilet bowl. We're not doing God a favor. And I think also God didn't want us to eat it because of the original sin of Adam and Eve, you know, with the apple. But what I really want to say is that people are aware, but not fully aware of what fructose is doing. If you take sucrose, which is table sugar, 50% is glucose and 50% is fructose. Fructose is found in high fructose corn syrups, fructans, and so many other packaged foods. The entire quantity of glucose is utilized by the entire body. When fructose goes up, it does not raise sugar, therefore it does not raise insulin, and that is why it got good press. But what the regulatory authorities did not tell us is that the fructose goes straight to the liver, gets converted into triglycerides, and then the insulin response comes and you store fat. And that's what is happening. Fructose is also creating uric acid, which is as a toxic byproduct of fructose metabolism. It reduces thermogenesis, it reduces WBC action, it reduces nitrous oxide. It's a horrible thing. You know, and I don't understand why people, don't get this point. When I tell somebody you can't eat fruit, he wants to hit me on my face. That's really true. I really want to bring a point. And I want to bring one last analogy on insulin. Which I find very effective, is you're going by and you bang your knee on a coffee table and you get a bruise. So a bruise is a natural reaction to injury and it contains itself. What do we do? Anybody, I just want some ideas. If you get a bruise, hit with the coffee table, your skin is not broken, your muscle is not broken, your ligaments are broken, what would you put on your bruise? What would you do? Anybody?
Ice
Sorry?
pack?
Yeah, anything else? Some cream or something? Yeah. You see, that's it. We do not need anything. Our body is going to treat the bruise. And we normally put some cream. And then we make $1 trillion industry on cream, that this cream lasts for 24 hours, this cream is after breakfast, this cream is after dinner. That's what we call insulin. And we really don't need it. You know, this is the simplest analogy of not using insulin ever.
Sure.
I could talk for 24 hours on that, but I can sum it up if you like. You see, fasting is an essential phenomena. It is not something which is a fad. I don't like to use the word intermittent fasting or keto diets because it's become such a fad. People ask me, do you do intermittent fasting? I said, no. They said, no, we thought you were the guy who started in India. I said, well, I'm just doing what I'm supposed to do. Again, going back to ancestral past, after a bit of workout in the morning, they had a big first meal. Sun went down, there was no electricity, so little bit of diet which was left, they used to eat. So they had a short, 8-ish hour eating window and a 16-hour, non-eating window. And in those 16 hours, many things are happening. Your body is getting repaired, your immune system is getting repaired. There's a wonderful word called hormesis, which is that, what doesn't kill you makes you stronger. A little bit of poison is good for you. Many times when you are fasting, certain cells will die. They will, the degenerating cells, the precancer cells. And what doesn't die are our stem cells, which are hiding for a rainy day. And we are creating that rainy day so that they come out. So the best way to do it is actually, to make it simple, is to make it easy to take a late breakfast and an early dinner. And that's as simple as we can put it. There are many ways of fasting, about 10, 15 ways. The simplest, the most researched one is the 16-8 method, where you don't eat for 16 hours and eat within an 8-hour window, which means you start at 11 and end before 7, or something like that. And prior to that, we should break our fast with the fat. I have what we call a bulletproof coffee in the morning, which is putting 2 tablespoons of olive oil, coconut oil, ghee or white butter in my coffee and shaking it up. Or I put a full fat, heavily whipped cream with cocoa without any sugar. Look like a Venetian's drinking that. But I'm on high octane, like I am at the moment, and it goes on till 7 o'clock when somebody has to remind me, hey, you got to eat. It really works. But you can come and sit with me and I can give you a ball-by-ball version of how to do it.
Dr. Debbie, my next question is to you, and more relating to technology again. How do you see new technology approaches impacting on diabetes care over the next 10 years?
So I think two main areas. I think type 1 diabetes we've not talked much about, but there's phenomenal steps forward in terms of technology. So we are now at the point we pretty much have bionic pancreases, so continuous glucose systems linking to insulin pumps with automated algorithms that will deliver insulin in a pretty much automated way. There's still some challenges with that during the waking period related to exercise and food, but these closed loop systems are going to absolutely transform type 1 diabetes and are already doing so to some extent, I'd say within the UK, where we're now using more Abbott Libras and continuous monitoring systems. So type 1 diabetes looks great. I think islet cell transplantation as well, big difference, but I think that will only really be rolled out once stem cell therapies allow us to deliver islet cells that aren't immunogenic so that we don't need immunosuppressive therapies. Type 2 diabetes, I think the main ways in which technology will support is around things like apps and AI to support behaviour change that I've talked about, but also to help support things like personalised medicine and personalised treatment responses. And you've heard about type 2 diabetes not being one disease, but being multiple diseases. And there's now a lot of work going into how we check genetics, how we can check other biomarkers to really start to work out which people have which type of diabetes to give them very specific treatments that will support them. So I think that's the main ways I think technology, AI, data will really help us going forward.
Sure. Thank you. So basically, Dr. Sharma, I'd like to ask you, so when we talk about technology, what role does it play with compliance? Since like we've been discussing, a lot of lifestyle changes need to be adopted by the patients. And would you like to comment on this?
Yes, absolutely. Thank you. So fundamentally, I believe that we have to move from rescue medicine, which is the medicine what we do, to restorative medicine, which is that you help people fix what is broken in their own, by their own actions. So in compliance monitoring, one of the biggest issues in medicine today is that when something happens, you go to the doctor running, you get a medicine, you get a false sense of relaxation that, oh, everything is taken care of, and you continue to insult your body. And that continuous insult of the body is that sometimes for a while, for a few months, you will take the medicine well, then you will start being non-compliant on the dosage. You will start even becoming non-compliant and start increasing the triggers of the disease. And finally, you go back to the doctor when there's another episode, another event, which pushes you to the doctor. Now in compliance, what we do as a company is, that we have about 140 doctors and nutritionists who are in the company and who call the patient every second day. We call the patient every second day and we check on them. We check in to see that what is the kind of diets they have followed, what are the issues they have faced. Many patients actually, we have different kinds of patients. Some patients prefer a video call, so we talk to them on a video. Some people just prefer a chat, so it is a text conversation, and some people like a voice. But the fundamental understanding is that if you don't check in with the patient every second, third day, they are more likely to go back to their lifestyle which is harming their body. Because whether we like it or we don't like it, the patient is in an environment which is toxic for that person. Their diet, their lifestyle, their belief system, the stressors, it's a toxic environment. And while they have been rescued once, if they don't change their diet or lifestyle, it will be hard to rescue them again and again. So I always compare it, if you're at a swimming pool and you fall into the pool, the lifeguard will save you, and that's what modern medicine does. It's a rescue medicine. But if you keep falling into the pool again and again, how many times can the lifeguard be around? So that's where compliance monitoring becomes very important, and shifting the responsibility from the doctor to the patient.
Thank you, ma'am. So actually, I was reading a study, and I'll quickly try to wrap up in the next couple of minutes, by the PwC, that says that the total bill for treating this condition would reach approximately US $30 billion by 2025, by the current estimates. Dr. Debbie, would you like to comment on what can we actually do to bring down the cost of this treatment?
I think a lot of it comes down to what we've heard today. The cost, 80% of the cost is complications. It's treating the heart attack, strokes, kidney failure, amputations, blindness, all these treatments. And so we need to really focus on preventing the complications happening, and also reducing the amount of pharmaceuticals that we're using, because both of those items are the massive cost to the system. So it's about early prevention. It's about using low-cost solutions, like technology solutions that can deliver at really low cost, lifestyle interventions that can effectively improve lifestyle, and aiming towards diabetes reversal. So I think it's just a completely different focus away from the current medical model of care, which is often driven by pharma, driven by reactive medicine, reacting to complications happening, rather than investing our time, efforts and money into the things that are actually going to stop these things happening in the first place. So that's where I would put my money.
Yeah. So I completely agree with you. So please.
Just to add to the technology thing, we have a new device coming up, and see what happens in that device. You activate your beta cells by the ultrasonic waves. You activate the beta cells, and you can really monitor the effect within 20 to 30 minutes. You attach the device, you take the reading before attaching the device, then after half an hour you take the reading. You will see that glucose level coming down. I mean, it becomes absolutely normal kind of thing. So daily doing it twice in the morning and do it in the evening, I think this is a good way of controlling your diabetes, because you are not involving any medication costs and all that. So, but lot of research is required for this. I don't know, but this device is there in the market.
Sure.
I'd just like to add on this that we are also working on a pulse electromagnetic frequency machine, where we are actually mapping out the meridians of the defect, and we have used successfully, I mean, not researched properly, acupuncture to reduce this, and it is changing those biomarkers. And we are involved with a research company, which is Dabur Research, and we are actually doing whatever I'm doing, I'm trying to validate it so that I ultimately can show real results with this.
Thank you, everyone. Very thought-provoking comments and expert opinions. Thank you to everyone. Thank you for your attention.
That is what Sachin could achieve it, behavior modification. We hosted a delegation of Israel, one of the university who claimed to have But I think that's the crux of the problem. If we don't do the nutrition, we don't do other things, everything will go down. Thank you.
So, excellent moderation, Dr. Arjun, and I think this session could go for 24 hours because there's so much to learn, and you could see from, published work which takes years to experiments at individual level to institutional level. I think we need to reconcile. That was, one idea of this panel, to bring a very diverse set of view. Maybe you guys are too nice to each other not to disagree. Maybe you're too much agreeing, but I think as a normal individual, I am lost, often, because it takes a lot of money to find the claims of that person who is claiming, for me to test. For me, I would believe in science, and the thing that is difficult for me is that most of the Indian people, they are not publishing. If they're not publishing, I am lost. I am paying with my pocket thousands, tens of thousands of rupees before I know this works or doesn't. So I would encourage, we are running short of time, that we have eminent experts available and you want to ask them all kind of questions. So we will break for tea now, but before we break for tea, may I request Dr. Arjun, can you felicitate our eminent guest here, starting with Annie. May I request Annie, can you felicitate Dr. Arjun? So a heartfelt thanks again to all of you, and I really value, I think, if I were to pay for this conference, this session has already given me my money back. I don't know about others. So I would like to keep in touch with all of you, learn from you. And as I say that we need to, it should not be my truth, If it is truth, then it is truth. So, sir, you may agree or disagree with me, but if it is truth, we need to spread it. And the only way to spread it is to do science. Thank you.
Thank you.